Other questions? So what kind of issues are y'all running into? Any? The derivative ain't so nice, right? So like in the examples I did last class, it was just to get the idea down, right? And the functions I gave you were very simple in terms of taking derivatives. But really, the point of this is to be able to do this for more complicated functions like this. So let's start with that first step of finding the critical numbers. The critical numbers of a function are wherever the derivative is 0 or where the derivative doesn't exist. So first thing I need is the derivative. Let's work on that together here. So the derivative of this function, what am I going to need to take that derivative? Product rule, right? I need a product rule, and then there's also going to be some chain rule in here. So I see I have a product here. So I do derivative first times the second plus derivative second times the first, right? What's the derivative of the first function? 1. So I'm not going to write 1. Times the second function plus, now, the derivative of the square root of something, right? So derivative of the square root of something is 1 over 2 times the square root of that something. I'm going to start with that. 1 over 2 times the square root of that something. And then, chain rule, I have to take derivative of what's inside, or what's underneath the root. What's the derivative of what's underneath there? Negative 2x, right? Negative 2x. I'm going to put that right here, negative 2x. And then, am I done? No, I have to finish the product rule, right? So I have to multiply this times the x out here in front. And like I told y'all last time, you know, we're so used to working with the raw derivative, right? But now we're going to have to set this equal to 0. So we're going to need to be able to clean this up, right? So let me try and simplify a little bit. Tell me if you agree or not. How about this? Oh, you know what? I don't need that. I don't need the 2. Who wants to help explain what happened there, algebra-wise? What happened? What did I do? I put those two together. That was negative 2x squared. The 2's cancel each other out. And then what about the negative? I changed the plus to minus, right? Everyone got that algebra there? All right, that's our derivative, right? That's our derivative. Now, I need to figure out where that's 0, and I also need to figure out where it's undefined or where it doesn't exist. If you're coming in late, this wasn't a quiz. I just forgot my SD card down in my office, so I had everyone start on this problem. But we're working through it now. So I need to figure out now, for the critical numbers, first, where's the derivative 0, right? So I need to set that equal to 0. And as bad as this looks, we're just going to systematically go through and try and solve this equation, right? So whenever I see multiple terms like this equal to 0 and I have fractions, I try and get it all into one term. So I try and get a common denominator between the two. So I look at this first one as this over 1. And then my common denominator is this right here. I need to make this appear in both denominators so that I can put them together, right? So that means I need to multiply this fraction over here by something over something. What is it going to be? Square root of 9 minus x squared over square root of 9 minus x squared on top and bottom. That way they both have the same denominators. What do I get when I multiply those two together? And they're the same thing, aren't they? So when you do square root of something times square root of the same thing, the root goes away, right? So you're just left with 9 minus x squared over square root of 9 minus x squared, and then minus x squared over the square root of 9 minus x squared equals 0. So All I've done there is algebra, right? Just to get the same denominator. Now I can put these two together, and what I mean by that is I can take this and subtract that and put it all over the same denominator. I'll do that right here. Are there any questions right now? Okay, so what do I get up top when I do this and then take away x squared? 9 minus 2x squared, right? Yeah, 9 minus 2x squared, and then over my common denominator, square root of 9 minus x squared, and then equals 0. Now, the whole reason I did that is because I want to use what I did last class, which was, remember when I said whenever you have a fraction equal to 0, all you really have to do is look at when the top is 0, right? So I was trying to get it into a single fraction so that now all I have to do is look at the top. Understand? So I'm going to, now from this, I'm going to say that all I have to look at is when is 9 minus 2x squared equals 0. And that's a quadratic equation, right? It's quadratic. And there's all sorts of different ways to solve quadratic equations, right? You quadratic formula, you can try and factor. For this one, all I'm going to do is add the 2x squared to both sides. I'm doing that so I can now divide both sides by 2. I'm trying to isolate that x squared, right? I'm trying to get it by itself. And finally, take the square root on both sides. So square root on the left, square root on the right. What am I missing? I'm missing something. What did I just do on that step? I took the square root, which means I have to do plus or minus. Anytime you take the square root, anytime you initiate the square root on both sides of an equation, you have to have plus or minus. All right, there we go. I have 2 answers, right? 2 critical numbers so far. What do I need to do with these? There's something I'm not quite done yet. Can I make this 3 over the square root of 2 and then negative 3 over the square root of 2? Y'all know what I'm doing there? Taking the root of a fraction, take the root of the top and bottom separately. That's okay. Are both of these critical numbers, yes or no? Are they both critical numbers or not? What do I need to check? Are they in the domain of the original function? So are these numbers between -1 and 3? So you might need a calculator here, right, to double check. Maybe someone can check for me. 3 divided by, this is 1.414 something, so this number is actually bigger, 2 point something, and -2 point something, right? So that means I'm going to keep them both. What do I do? Keep the positive one throughout the negative one, right? That one is not in the domain. Y'all got this? Are there any questions? Y'all give me a look like I'm teaching German class and none of us know German. Are y'all all right? Just the weather, tired? Yeah? Okay. All right, so I've only figured out where the derivative is 0. There's no questions on that algebra. Y'all are okay? It's easy watching me, right? It's when you have to do it yourself is when it's hard. The next step is to figure out where the derivative does not exist, right? So I'm gonna go to that step now. So where does the derivative not exist? Does not exist, or where is it undefined? So let's take a look at the derivative again. I'm going to write it down so we can look at it. And I'm going to write down the derivative. How do we want it? The first way I had it? Or do y'all want me to look at that one? That one or the original? This one? Yeah, I like that one. I mean, we already did that work, so that is the derivative, isn't it? All we did was got a common denominator. Okay, so we look at this and we ask ourselves, hey, is that ever going to have a problem, right? Is there ever a value of x that I can plug in that's going to make this thing like mess up, right? Well, the only thing that's going to mess this up is if something in here, right, something in here creates either a 0, right, either a 0 or a negative number, right? So what's under here has to be strictly a positive number. It can't be 0 because if it's 0, I'm dividing by 0, and it can't be negative under here or else I'm trying to take the square root of a negative number, which I can't. So can you all think of what would make this 0? 3 or negative 3, right? 3 or negative 3 would make that 0. Is 3 or negative 3 in our domain? Yeah, 3 is in our domain, right? So 3 is a critical number so far. Now, is there anything that would make this negative? A lot of things would make this negative, right? But just think about this for a second. If this is ever negative, then wouldn't this be negative? And then this wouldn't be defined. In other words, whatever makes this have a problem would also make this have a problem, which means that would not be in our domain. When you plug 3 in, we didn't have that issue. See, if we plug in 3, this is not defined, right? If I plug in 3, it's division by 0. Can I plug 3 into that? Can I plug 3 in here?
Yes.
Yes, because you can do 9 minus 9, that's 0. The square root of 0 is 0. See, we're not dividing by 0 here. So it's okay to plug 3 in here, just not there. But if let's say we plug in 4, right? What would happen if I plug in 4? 16? 9 minus 16 is negative. I can't plug 4 into this, right? But I can't plug 4 into that either. You see, it's outside the domain. And basically every number in here has to be, this has to be defined at every number in this interval, or else the problem doesn't make sense. If I give you a problem like this and I give you an interval and that interval has points that don't work in there, then I've messed up. Like I've messed up by giving you that problem. So the conclusion I'm trying to get you to see is that this is the only critical number I have to worry about, because any other number that would cause this to have a problem is not in the domain of the original function. You clear on that, or questions? Yes? Yeah, if we didn't have the interval, then we would actually have to go figure out what the strict domain of this thing is. That's not the next section, the section after that. So this section we're talking about functions on closed intervals only, and then in 4.3, this is 4.1. In 4.3, we talk about functions where the domain is like the entire real number line, or the domain is not restricted. So there's a different technique. We use a different procedure for that. All right, so I have my critical numbers, yeah? I'm going to proceed. So what I do now, still in step 1, is I found the critical numbers, and now I evaluate the original function at those critical numbers. So I'm going to come over here, and my two critical numbers are 3 and 3 over root 2. So I'm going to put here into the original function, I'm going to plug in 3, and then into the original function, I'm going to plug in 3 over the square root of 2. Okay, if I plug 3 into the original function, I get 3 times the square root of 9 minus 9, and we already know that's 0, right? And then this one is 3 over root 2, and then times the square root of 9 minus 3 over root 2 squared, which is 3 over root 2 times the square root of 9 minus 9 halves, right? Square the top and bottom. How do you do this? Common denominator, right? So I turn that into 18 over 2 minus 9 over 2. And that's 9 over 2 again, isn't it? So here's where I am. I have that this f of 3 is 0, and that's one answer. And then this, let me just squeeze that in here. This is 3 over root 2 times the square root of 9 over 2. That's weird looking. Isn't that weird looking? Let's do this again. What is this? This is 3 over root 2 again, isn't it? So I have 3 over root 2 times 3 over root 2 again, and then multiply across, and you should get 9 over 2, 9 halves. 9, root 2 times root 2 is 2. So 9 halves. I'm just going to put that answer here. This is 9 over 2. 9 over 2 is 4.5. Questions? I've been doing this, I've been teaching calculus for 20 years. And the looks on your faces are the looks of confusion. And I'm trying to interpret if it truly is confusion, or is just this class? This is just your natural demeanor? You know what I mean? It's hard for me to turn around and see your faces and not get questions, and I just keep going. Yes? I'm trying to subtract 9, take away a half, right? How do you subtract numbers? I need a common, I do 9 over 1, I get a common denominator, multiply by 2, get 18 over 2. Yes? Okay. Yeah, so ask questions. I mean, you're probably not alone, all right? So everyone's good here?
What's the step you did after when the arrow points out?
Okay, I did, when you have the square root of a fraction, right? I do the square root on top and bottom separately. What's square root of 9? What's square root of 2? Got it? Anything else?
So what does that give us? That's,
This right here?
yeah.
Well, now multiply fractions straight across. So 3 times 3 is 9. Root 2 times root 2, the root goes away, so you get 2 on the bottom. All right, so right now I know that at my critical numbers, I get a 0 that comes out and I get a 9 halves. I don't know if that's the smallest or biggest yet, because I still have to look at what? The 2 endpoints. Yes?
So the critical number is just 3 and then 3 over root.
Yeah, these were my only 2 critical numbers.
And we got 3 because
That's where the derivative did not exist, because when we try and plug 3 into the derivative, we got division by 0, which is undefined.
not the original.
Not the original. You're asking where the 3 came from. It came from what made the derivative undefined. Once we figure out what makes the derivative undefined, we take that number and plug it into the original function to see what the value is. Because we know from last class that if we have maxes and mins, they have to occur either at the endpoints or at the critical numbers. So we go find the critical numbers, we go find the endpoints, well, the endpoints are given, and then we just plug them into the original function and compare the answers. So what we've done so far is we've looked at the critical numbers, we know the value of the original function at those critical numbers, and now we're just going to look at the 2 endpoints, -1 and 3, and plug those numbers into the original function. So I already did 3, right? This critical number happened to be an endpoint, right? So I already know the answer there is 0. But I haven't plugged -1 into that, so let's do that. -1 square root of 9 minus -1 squared equals -1 times the square root of, what? 8? So that's -√8. So this function, right? This function right here, if you look at it between -1 and 3, here's what I can tell you. The absolute maximum value of that function is what? On that interval. What's the biggest number that you see from the 3 answers we have here? 9 over 2. 9 halves. 4.5. That is the highest that graph should go. And then what's the absolute minimum? What's the smallest number you see here? Smallest as in biggest negative, not smallest, but on a number line. -√8. There we go. So I'm going to go to Desmos to confirm this. Maybe. Let's see. Here we go. So f of x equals x times the square root of 9 minus x squared. And we want to look at this only between -1 less than or equal to x less than or equal to 3. Yeah, that's not the way you type. Less than or equal. There we go. All right. So let's take a look at this function. See the highest value? What do we get? Right here? What the heck? Yeah, that's 4.5. That's the highest value, right? And then the lowest value is right here. So what are the coordinates of this point? What's the x coordinate? So where did that negative root 8 happen? -1, right? When we plug -1 into the original function, we got negative root 8. Okay, and then where the max value was 9/2, but where did it happen? It happened at 3 over root 2, right? When we plugged 3 over root 2 in, we got 9/2. So that's those 2 points. See, we found them. Without the picture, we found those 2 points. I'll use Desmos, see what it says here. Yeah. So if you take 3 and divide it by root 2, you get 2.121, and then 9 over 2 is 4.5, right? And then, of course, it's not going to give me the left endpoint. I have to drag to it, so there you go. -1, and then negative square root of 8 is about 2.828. Okay, what do y'all think? What's tricky about this to you so far? Like, just that there's a lot of stuff to do, or what? You got to get the right derivative? Oh yeah, if you get the derivative wrong, it's all going to be bad from there, right? So this is where, you know, I can never stress this enough in the beginning of a calculus class, that, you know, calculus, you've got the calculus part, right? But then you have the algebra part of the class. And up to this point, we've kind of avoided the algebra, right? So that we could focus on the calculus, raw derivatives, raw derivatives, raw derivatives. But I've been telling you that, you know, you need to be taking your answers and trying to see if you can get them to match the e-book's answer, right? And the point of that is that you need to be practicing your algebra, because now it's essential. Let's do another one. F of x equals, let's go with this one, x minus 2 inverse tangent of x, and we want this on the interval 0, 4. This is just to show you, like, there is really now no restriction on what we should be able to do. Like any function somebody feeds us, we should be able to take the derivative of it. We've learned all the rules for differentiation in Cal 1. There's no more rules to learn. So any function we're given, we should be able to, well, in theory, take its derivative. Then the question becomes, can you figure out where that derivative is 0, and can you figure out where that derivative doesn't exist? So let's start with the derivative. So instructions here are the same. Find the absolute maximum minimum on that interval. So first step, I'm going to take the derivative. What's the derivative of that? Who wants it? Raise your hand. You want it? Go. Yeah, go. You can do it.
We need 1
1, right? Okay.
minus the derivative of the first one. Does that need fire?
You don't need it. You can do it, but that's a constant, right?
Yes.
So you can just bring it with us.
Yes. Correct.
So let's just put 2 there. And now, do you recall this, or you know you can look it up? Do you remember it? 1 over
1
plus x squared. There you go. Perfect. Good. 1 over 1 plus x squared. Now that's one of the ones I told you should try and learn as soon as you can, because in Cal 2 we use that one all the time. Right, so the derivative of arctangent of x is this. If you're wondering why, you're going to have to go back and look in your lecture notes. We proved this, that the derivative of this is this. And that's it, right? That's your derivative. We can clean it up a little bit. There's not a whole lot of cleaning to do, though. We have 1 minus, I can just put that 2 up here. 2 over 1 plus x squared. There we go. That's our derivative. What are we going to do with that? Figure out where it's 0, right? And then we're going to figure out where it doesn't exist. So let's start with the derivative being 0. I set it equal to 0. Any ideas on how I'm going to set that equal to 0? What I'm going to do now? Common denominator. Like bring them together, right? Bring these two terms together into one term, and that will create a fraction, and then you can just look at when the top is 0. So if I put these together, what I'm going to have to do is I'm going to have to take this 1, look at that 1 over there as a 1 over 1, and then multiply the top and bottom of it by what? 1 plus x squared. Top and bottom, like that. And that allows me to rewrite this as 1 plus x squared over 1 plus x squared minus 2 over 1 plus x squared equals 0. Then I put them together. 1 plus x squared take away 2 all over the common denominator 1 plus x squared equals 0. And I can do 1 minus 2. 1 minus 2 is negative 1, so I get x squared minus 1 on top, and I get 1 plus x squared on the bottom like that. Any questions there? Sure? Cancel the x squareds? Hell no, you better not do that, right? Don't cancel. You can't cancel those, right? There's not multiplication between these, right? So you can't, don't do, I see this stuff, right? People be taking tests, they're stressed out, they do something crazy like that. Like, I say crazy, it's not crazy. There's crazier things that you can do, but you know, that's just an algebra-like mistake, right? Be careful, take your time. So that's it though, right? That's my fraction. I'm just gonna look at where the top is 0 now, all right? So from here, I'm just gonna deduce from that a over b is 0, that I just need to know when x squared minus 1 is 0. I'm going to do this one a little different than I did the last one. I could bring the 1 over, right? And then take the square root on both sides. But I could also notice that's a difference of squares. And I could say that that's x plus 1, x minus 1. And then set each of those equal to 0. And I'm going to get the same two answers had I done it with the square root. I get 1 and negative 1. So my answers here, without showing any work, are x equals 1 and negative 1. Two different answers. So do I have two critical numbers? No. How many do I have? Just one. You're going to throw one of those away. Because you, again, have to refer back to where you're looking, right? You're only looking between here and here. Because of that, we're going to throw out the negative 1. Please don't be thinking like, oh, anytime I get answers, anytime it's negative, I throw it out. That's not what I'm saying. You have to check to see if it lives in the interval or not. So if that interval went from negative 4 to 4, we'd keep them both, right? But it goes from 0 to 4, so I'm only keeping the positive answer. All right, next thing. I need to know if the derivative ever doesn't exist, or if it's ever undefined. What's that? Okay, why is it never undefined? Let's look at this right here. You're looking at this one right here? Why is that never undefined? Do you want to elaborate?
No number that you plug into x becomes or equal, like divide by 0.
Yeah, there's no way you could ever divide by 0 here. Because, look, no matter what you do, x squared is going to be positive, right? Worst case scenario, it's 0. If I take a number that's either 0 or positive and I add 1, there's no way that that's ever going to be 0, right? Never. So this can never be 0. And since that can never be 0, I never have to worry about division by 0. And other than that, there's nothing else in the function to worry about. There's no square roots, right? So Nothing. That means I only have one critical number, the number 1. So now I'm going to evaluate my function. I'm still in step 1. I'm now going to take my original function and evaluate it at my critical number 1. And that means I need to plug in 1 minus 2 inverse tangent of 1. Uh-oh. Don't do it. Don't grab your calculator. Don't do it. You could grab your calculator, right? You could right now? You could. You'd have to make sure you know what mode you're in because the answer it's going to give you is going to depend on what mode you're in. I want us to think about this rather than going to our calculator. I want you to think about what this means, right? So that we're going back to pre-cal right now. So in pre-cal, if you're trying to figure out what inverse tangent of 1 is, what this is really saying is this: tangent, not inverse tangent, tangent of some angle equals 1. And we're trying to figure out what angle gives you a value of 1 when you do tangent. So going back to your unit circle, which hopefully this is the way you learned it, the question is, where on this unit circle, at what angle, is your tangent 1? Tangent is defined to be your y-coordinate divided by your x-coordinate. So where on here is your y-coordinate divided by your x-coordinate equal to 1? 45 degrees, or pi over 4. Right here, because this is the ordered pair, root 2 over 2, root 2 over 2. And if I take the y-coordinate and divide by the x, I get the ratio of 1. Right? Is that the only angle that this happens? Where else? Right across, right? Like this? So why am I not going to put that angle? Why am I only going to put this angle pi over 4? No, because this is not, we plugged in x equals 1, and that's in here. We're just looking at what the output is. There's another reason why we're not looking at any other angles. Yes, sir. Oh, yeah.
Inverse tangent, and it has a domain restriction.
Exactly. This right here is an inverse tangent function. And in pre-cal, when we're dealing with inverse trig functions, there's domain restrictions for the exact reason that we do not want to have multiple answers. We only want to have one. So the domain restriction for arctan is, anyone remember what it is? It's only the right side of the y-axis, so it's over here. You throw out any answers over there. You're only allowed to get angles between negative pi over 2 and pi over 2. All answers for the inverse, all answers that come out of an inverse tangent function must be angles between negative pi over 2 and pi over 2. Negative pi over 2 and pi over 2. And so pi over 4 is the only answer that satisfies that. So I'm not here to redo pre-cal. I'm just pointing out this is the better way.